Okay, can y'all see that? There we go. Is that a dog?
Yes, ma'am.
Okay. Okay. Just give me a thumbs up when you're done, friendly. Ethan, did you get the ones at the bottom finished? The odd numbers on the bottom, that was cumulative review. Did you finish those ones?
No, ma'am.
If you're having questions, remember you can always send me a message and I can help you, okay?
Okay.
So we don't get too far behind. All right. Brindley, you good? You're muted. Oops. Okay. All right. Do you check these ones down here at the bottom too, Brindley?
Not yet.
Okay. All right. Let's go ahead and take a look at some of these. So let me get my whiteboard up. So here we go. Ethan, give me one from numbers 23 through 26. Which number?
23.
Okay, let's start with 23.
I didn't understand what it was asking for.
All right, so they give you parallelograms. All right, you can see your parallelograms. I'm just gonna. All right, it wants you to find the ratio of the corresponding sides. Okay, well, what's a ratio, Ethan?
It's comparison of numbers in fraction form.
How many numbers, Ethan?
Ma'am?
A comparison of how many numbers?
2.
2 numbers. So we can write it in fraction form. So a number compared to another number. Notice our parallelograms here. We have, let's see here. This side is 8, this side is 10, and then it gives us the area is 64 square millimeters. Over here, it doesn't give us any of the sides or the height. It doesn't even give us the height. All it gives us is that the area is 400 millimeters squared. Well, remember, the ratio of corresponding sides is equal to the area of the two areas. So the area of the smaller parallelogram over the area of the larger parallelogram is going to be equal to, or we can set a proportion equal to, let's see, one of the sides, which is 8, over, well, this is the corresponding side with 8, but do we know what that side is? No. So we're just going to represent it as x. But there's one last thing we have to remember. because these are areas, the ratio that the areas are equal to are going to be squared. You with me, Ethan? Does that make sense? Okay. Sorry, I couldn't hear you. All right. So this is going to be 8 squared over x squared is going to be equal to the areas of the other two parallelograms. So that's 64 over x squared is equal to 64 over 100. How do I solve proportions? Cross multiply. So 64 times x squared is equal to 64 times 100. What's 64 times 100? Well, that's 6,400. So I'm just going to go ahead and put 6,400 there instead. We're solving for x because we're trying to solve. We've got to find one of the sides first before we can write a ratio of the corresponding sides. So divide both sides by 64. X squared is equal to 100. So therefore, what is x? Ethan, what would x be?
10.
So this side is equal to 10. Now we're not done yet. The directions, number 23 says we need a ratio of the corresponding sides. So side 8 corresponds with side 10. So 8 over 10, and that can be reduced down to, 8 divided by 2 can be reduced down to 4 over 5. Let's see here. What did I do wrong? Square root of 64. Oh. Stinkpotamus. I'm sorry. Stinky, stinky, stinky. Scratch what I just said. You ready? That's dumb. Okay. Here are the two parallelograms. Chick-fil-A. The Chick-fil-A without me. He went to Chick-fil-A without me. What in the world? Okay. Here we go. These two parallelograms are similar, correct? The ratio of the corresponding sides. Therefore, we have to find what one of these sides is, correct? Well, we know that the corresponding sides of the smaller parallelogram to the bigger parallelogram will be 64 to 400. Again, that's this squared. This ratio is squared because we're dealing with areas. So therefore, this is x squared, x sub 1 squared, x sub 2 squared. That's going to be 64 over 400. Well, we're not really going to cross multiply to figure this out because these are two different variables. If we cross multiplied, we'd still have two unknowns. But we do know that the square root of those will get us x sub 1. So x sub 1 is 8 and x sub 2 is 20. Therefore, the ratio is side 8 to side 20, which would be 2 to 5. Let me do another one. Number 24. Let's do number 24. So we're trying to find side UX, correct? Side UX, here's my little parallelogram. Here's my big one. This is side UX. We're trying to find what that value is. We don't know what it is just yet. Let's not use y because they use y right there. So what do you want to use, Ethan? Or do you care? Oh, I can't unmute you. What'd you say?
So V.
V. Okay. So
I'm trying to keep my microphone muted as much as I can because of the wind.
that's fine. Go ahead. You can mute yourself, or I'll mute you. There you go. So we're finding side UX. Well, over here we know that this side is 8. This side is 10. The area is 400 square millimeters. And this area is 64 square millimeters. We can use the areas of parallelograms to set proportions up. So side 10 corresponds to side, or the length of V, because we're trying to find UX. So proportionate sides, corresponding sides, 10 over V. But remember, corresponding sides are proportionate, or they're equal to the areas of the parallelograms as well too. So side 10 and the area of 64, side V and the area of the big parallelogram, which is 400. But it's not proportionate in and of itself, it's proportionate to its square. Now when we're dealing with perimeter, we don't have to square it, okay? So we've got 10 squared over V squared is equal to 64 over 400. Let's cross multiply. 10 squared is 100. So I've got 100 times 400 is equal to 64 V squared. 100 times 400, that's 4,000, is equal to 64 V squared. Divide both sides by 64. 4,000 divided by 64 is 62.5. And what's the square root of 62.5? So side V would be about 7.9, and we're talking about millimeters. So side V would be about, what did I do? They're frustrating.
Miss Lauren.
What is 100 times 400?
40,000.
Thank you. Man, what is going on today? All right, what is 40,000 divided by 64? 625. What is the square root? 25 is, what's the square root of 625? 20. So therefore, what is segment UX? Value of V, which is 25 millimeters. Let's do another one, okay? Let's do number 25. Here we go. I'm gonna leave my pictures there. All right, now number 25, we're looking for segment VY. Yes.
Can I run and get my calculator real quick?
Yes.
I didn't think about it.
Okay. So now we want to find VY. Well, VY is going to be the height of this parallelogram, correct? So we're looking for the height there. Wait a second. What was the distance of UX? What do we find that to be? 25 millimeters, right?
Yes.
So, here, I'll wait till he gets back. Hey, you don't have to feel embarrassed that you missed this. This one is a hard topic, okay? You don't have to feel embarrassed. We're going to go through a bunch of them. All right, let's see here. This one, number 25, this one you have to think. We're looking for the height, which is Vy. That's the height of a parallelogram. Okay, do I know the height of this guy right here? Do I know that height of the first little parallelogram? Because remember, I can set, if I know the height of the first parallelogram, I can set a ratio with the height of the second parallelogram. But do I know the height of the first one?
No, but you could divide 64 by 10.
Okay. Why would we find the height of the first one if we could do that same thing with the second parallelogram to find the height? What is the
Find the height of the second one.
What's the area of a parallelogram? It's base times height, right? Well, do we know the area of this parallelogram? Sure. 400. Do we know the base? Well, we just found it in number 24. The base was 25. Can we find the height then, which would be segment y? We can indeed divide both sides by 25. So the height, or segment Vy for number 25, is going to be 16 millimeters. All right, let's deal with the perimeter then. Oops. Okay, Priscilla maybe texted me. Number 26. I don't want to clear all drawings. So we have found the height, we have found the base, we have found the ratio. So the height was segment Vy, that's 16 millimeters. So the perimeter of UVWX, in order to find the perimeter of the parallelogram, I need to find all of the sides, correct? Well, let's go over here to the first one. What is this length right here? What is QR?
10.
Yeah, because opposite sides of a parallelogram are congruent. What about RS then?
8.
It would be 8. So what is the perimeter of this first parallelogram?
64.
Would be, the perimeter is the distance.
Oh, sorry.
1 plus 8. 8
36.
is 36. So 36 millimeters is the perimeter of this one. Remember, we have a relationship between the perimeters of the parallelogram. So, the ratio of corresponding sides. So do I know corresponding sides? Sure. I know that side PS, which is 10, and side UX, which is 25, those are corresponding sides, correct? So those are corresponding sides. I know that corresponding sides are going to be equal to the perimeters. So side 10 relates to the perimeter of the first parallelogram. So therefore, I can find the perimeter of the second parallelogram by setting up a proportion. So multiply, cross multiply, 25 times 36. Um,
900.
So 10x is equal to 900. Divide both sides by 10. X is 90. So the perimeter of this big parallelogram should be 90 millimeters. If that's the case, this side up here is 25, 25, and 25 is 50. What must side UV and XW be? If the perimeter is
90.
the perimeter is 90, this side is 25, this side is 25, what must these two sides be? Well, remember, perimeter is the distance from it. So 90 minus 25 minus 25, well, that's 90 minus 50. So I'm left with 40.
20.
Yes. So both of these sides must be 20 as well, too. What was the ratio we found in number 23?
It was 64 over 400,
Well,
and then 10 over 10 over V, I think.
25. So ultimately, we found that our ratio of corresponding sides was 2 to 5, right? Let's
Mhm.
check that. Side PQ to side UV, those are corresponding sides, so that would be 8 to 20. Is 8 to 20 reduced down to 2 to 5? Let's see. What about side 10 to 25? Does that reduce down to my ratio 2 to 5? Yeah. If you were to do that with all the corresponding sides, your ratio would be 2 to 5. That's a helpful ratio to know. All right, let's look at number 27. Doubling the radius of a circle has what effect on the area? Okay, so we're dealing with area. So the area of a circle is pi r squared, correct? Now it's telling me double that radius. So if I double the radius, instead of saying r squared, it's now going to be 2r squared. Let's simplify. So now I've got, what is 2r squared? Remember that square is going to go to the 2 and to the r squared. That's like saying 2r times 2r. So that would be 4r squared. So now my new form, if the radius is doubled, it's now going to be 4 pi r squared. So what's the comparison here to the normal area if the radius gets doubled? What happens to the area?
It doubles.
Ooh, not doubles. This is 4 times the actual area.
Oh, it quadruples.
It quadruples the area. If I have a radius and I double it, what's going to happen to the total area of that circle? It's going to quadruple the whole area. What was the percent of increase in area then? Ooh,
400%.
9%. What is it?
400%.
400%. You're close though.
300%.
Yes, it's going to quadruple by 300%. Percent increase. So 3a over a times 100%. What was the percent increase? So 4 pi r squared minus pi r squared, that's pi r squared. So 3 times the area over what was the original area? Just the area. times 100%. So that's 300% is how much it's going to increase. Ooh, that one came out from a lot. All right, let's do number 28. Tripling the sides of a square has what effect on the area? Okay, what's the area of a square, Brinley?
Pi r s squared.
S squared. So if I were to triple the side, be careful. That is not tripling the side. That is tripling the area. If we were to triple the side, we are only multiplying 3 times the s, and then we're squaring that. So what happens to the area? 3s squared is going to be 9s squared. So here's my original area formula. If I tripled one of the sides, here's my new area. So what's the comparison there? What happens to it? What happens to the area? Well, it's multiplied by 9. So what would be the increase percentage in area? Well, what was the new 9s squared minus the original all over the original times 100%. So 9s squared minus s squared, that's 8s squared all over s squared times 100%. So the percent increase would be 800%. Cereal. All right, number 29. The area of a square can be doubled by multiplying each side by what factor? So the area of a square, which is a equals s squared, this area can be doubled or multiplied by 2 if each side s is multiplied by what factor? How do you figure this one out? What would I have to multiply this side by or multiply s by in order to get 2a?
The square root of 2.
You got it. If I multiply the square root of 2 times s and then squared that, what would I get? Would I get 2 times the area, or 2 times s squared? Is that what I'm going to get? Well, the square root of 2 times s times the square root of 2 times s, that's this squared. The square root of 2 times the square root of 2, that's the square root of 4. S times s is s squared. Square root of 4 is 2 times s squared. Is that equal to 2s squared? Yes, it is. So what would I have to multiply a side by? Square root of 2. Very good. How could I find that? Well, I go back up here. The area of a square is s squared. Area of a squared is s squared. So if I want that to equal 2 times s squared, what would I have to do? I would have to multiply, or excuse me, what would I have to multiply s by? I couldn't just multiply it by 2, because then that would be 4s squared. So the only thing that would work is, okay, well, what's the square root of both sides? Square root of 2? Square root of 2. There we go. All right, number 31. Find the ratio between the volumes of 2 cubes whose edges are 6 inches and 3 inches respectively. So here I've got a cube, or maybe, This is a really off cube. I apologize. Nah, that looks bad. Here I've got a cube. Oh my goodness. You draw a cube on your own. Here we go. Find the ratio between the volumes. So the volume of cube number 1 over the volume of cube number 2 have to correlate between 6 inches and 3 inches. Does anybody know what the volume of a cube is? The formula?
Um, 6s. Wait a minute. No, s
S
to the 6th power.
cubed. S cubed. So area is S squared, volume is S cubed. So earlier, the areas of figures corresponded to the square of the corresponding sides. So now if we're dealing with volume, what do you think I have to do to the sides here?
Cube them.
Yes. So what is the ratio between these two volumes, between these two cubes? 6 cubed over 3 cubed. So what's 6 cubed divided by 3 cubed?
Um,
That ratio. Well, 6 cubed, 36 times 6, 18. That's 190. Oh, excuse me, 216. 3 cubed is 27. So what's 216? Can that reduce 216 over 27? Did I do that right? 6 times 6, 36. 36 times 6 is 216. Yep. And then 3 times 3 is 9. 9 times 3 is 27. So 216 divided by 27. I can reduce this down to 8 over 1. So that's my ratio. The volume.
Miss Lauren?
Yeah.
If we have an option on our calculator to do like a cubed,
Yes.
like divide by that, can we do that?
Please. Yes. You can find the cube of 6 to the 3rd power. You're welcome to do that. If you don't have that button, then you can go 6 times 6 times 6 and do it that way. Okay. What do you think now? These making a little bit more sense?
Yes, ma'am.
I'm going to let you go back to your quizzes. Okay. Go back to your quiz if you need to fix some answers, especially on this specific lesson. Hopefully this is making a little bit more sense. If you don't need to go back to your quiz, then that's fine as well. All right, here's what we're going to do next. We're just going to review briefly. All right, we're not going to go super long. Yesterday we started with prisms, so just follow along here. Prisms. I name a prism based off of the shape of its base. So here I have rectangle bases. Therefore, this is a rectangular prism. It's a prism because both of the bases, this base right here and this base right here, they're both polygons and they're the same exact shape. They're parallel to one another. Here, my bases are triangles because both are triangles. Triangles are polygons, and they're parallel to one another. All right? It's a triangular prism. A cube is also known as a what? What kind of prism? You remember? What's another name for a cube? Well, check out the base. What kind of bases do we have in a cube?
Squares.
So this is also known as a square prism. The thing about a cube, though, all of the bases and the faces of a cube are all the same shape, so they're all squares. So cubes are nice and easy. The lateral surface area versus the surface area. What are the difference between the two? The lateral surface area is going to be all of the areas of the lateral faces, okay? Remember, lateral means like up and down, okay? So check out this rectangular prism. I have two bases. I have the top and the bottom base, correct? How many faces do I have? How many faces on this rectangular prism do I have?
4,
Yes.
6. Oh.
No, just 4. Think about a tissue box, okay? Where the tissues come out at the top here, okay? Here are the tissue, the little slit in the top. The tissues are coming out. This is the top base, and this is the bottom base. The bottom of the tissue box and the top of the tissue box, those are the bases, okay? That's how we name the prism. The faces are going to be the ones on the sides, the lateral faces, the up and downs. So we've got a square face on both ends, and then we've got 2 rectangle faces, one on the front and one on the other side. So we've got a front face, back face, left face, and a right face. So we have 4 faces here. 2 bases, top and bottom. Check out this triangular prism. We've got a triangle base up top and a triangle base on the bottom. How many faces are in a triangular prism? How many lateral faces do we have? Sorry, Brinley.
2.
3.
We have 3, yes. We've got the front here, which this is actually a rectangle. We've got one here in the back, and then on the other side, way down there, we've got this back side as well too. So we've got 3 lateral faces there. How many lateral faces do we have on a cube? Count
4.
4.
Yes, we have 4. Good. Okay. Lateral surface area. I'm going to say S, capital A. That stands for surface area. To find the lateral surface area, you need to find the area of each one of the faces and then add those up. So you're just getting the surface of the, so for this example right here, the surface area of a tissue box, all you want is the box. You're not worried about the tissues inside of it. That's going to be dealing with the volume. All you want to do is get the area of the box. So finding the surface, the lateral surface area, you would have to find the area of 4 different shapes. This rectangle right here, these 2 squares or rectangles on the ends, the front and the back, and then you'd have to find the area of that rectangle in the back as well too, on the right side there. The surface area, the total surface area, is just going to be the area of all of the shapes. So going back here to this rectangular prism, I would have to find the area. So to find the surface area, here we go. I need to find the area of all the sides of this rectangular prism. How many total sides do I have? Or how many total sides do I have? Yeah. How many total shapes make up a rectangular prism, including the faces and the bases? Okay, I have 6 total pieces that I have to find the area of. Let's see here. Let's talk about the bases. Are the bases the same exact shape? Take a look here. What kind of base do we have? What's the base of this figure right here? What shape
A
is it?
rectangle.
It's a rectangle. What's the area of a rectangle?
Length times width.
Length times width. We also have to find the area of this top base too. Is this top base the same as the bottom base?
Yes.
So if we find the area of the bottom, can't we just multiply that by 2 and that'll take care of the top base as well too?
Yes.
Okay. So we found 2 of the sides. We've got 4 more sides on this rectangular prism to find. So we find those 2 areas plus, all right, what about the front right here? Let's say we don't know that it's a square. Let's say it's a rectangle. What's the area of a rectangle? Length times width, right?
Mm-hmm.
And isn't this side over here the same exact as this piece over here? So we
Yes.
can just say, well, 2 times that. And then we've got the long triangle face right here. And we've got it on the other side back there too, which is also a rectangle. So it's length times width. And it's the same thing, so we can multiply with 12 too. So, find the area, the surface area. That will find the surface area. And we're going to talk about the specific type of, the specific type of formula. But that's the gist of when you're finding the surface area. It's like you're taking each side of that tissue box, find the area of that one rectangle. Got it. Find the area of the top rectangle. Find the area of the side rectangle. Up all of the areas together, and that will be the surface area of the total object. All right, I have to run for now. We'll finish up this lesson on Monday. So if you need to finish doing any of your homework from the past day or two, get that caught up, put it on Google Classroom. You need to finish your quiz, or if you need to go back to your quiz and fix some things. I haven't graded that quiz yet. We did not get to go over quiz number 1, so remind me to do that on Monday for sure. I have a Zoom meeting in about 3 minutes, so I'm going to have to run for now. So, see you guys later.